Hello everyone. In this video we're going to continue moving forward with our filtering in the Cubro Packet Master series of network packet brokers, and in this video we're going to look at MAC address filtering using the Web GUI interface. And what I have on screen right now is a PCAP that I'm going to use to demonstrate our MAC address filters. This is actually the same PCAP that I used in the VLAN filtering video. We're just going to reuse this for the MAC address filtering. And I have chosen two MAC addresses more or less at random out of this PCAP that exist as both source MAC addresses, destination MAC addresses, and a conversation pair with each other. So we'll be using these to build our filters with. With that out of the way, let's just jump into our EX2's Web GUI and go to our Add Rule page. And again, I'll be sending the PCAP in port 1 and collecting that traffic on port 4, just like the previous videos. And you'll notice that right underneath our VLAN dropdown that we looked at in our last GUI filtering video, we have a field for MAC source and a field for MAC destination. And I'm sure you're already guessing that if we want to filter on a specific source MAC address, we just put that MAC address in the MAC source field, and similarly with the MAC destination field, and you would be absolutely correct. So let's just go ahead and give that a try. Let's grab this MAC address, drop that into our MAC source field, and I will call this my MAC source filter. Let's apply that rule. Taking a look at the rule table, our overview shows that we are coming in port 1 with our traffic. We are going to filter out this specific source MAC address, and we're going to output that traffic on port 4. Let's fire up our Wireshark capture and play our PCAP into the EX2. And at first glance, it certainly looks like we only have traffic with that source MAC address, but let's just double check that to be sure. So eth.source does not equal, and then our filtered MAC address, and we don't have any traffic, so that filter worked exactly as we intended it to. So again, we can do this the same way, filtering on a destination MAC. So in port 1, out port 4, grab this MAC address and throw that in our MAC destination field, and continuing my creative naming convention, let's call this our MAC destination filter. Again, the rule table overview will show our traffic coming in port 1, filtering out this destination MAC address and outputting that on port 4. Start our Wireshark capture and play our traffic. And again, it certainly looks like our filter behaved exactly as we intended. And let's just do a sanity check on that. So eth.dst does not equal our MAC address. No traffic, just what we would and should expect. So of course we can filter out just a conversation between two nodes on the network by putting in these fields for both our source and our destination. Import 1, output 4. So our filter would look like this. Now this is really only half the filter, because if we want to see all of the communications going back and forth between these two hosts, this is only giving us what's sent from this host and ending up at this one. So this would be part 1 of our rule, and then we're just going to reverse these values to get the complete picture. And I don't think we have to do the PCAP to demonstrate this, but just so you can see what this would look like on the rule table. So in port 1, this is going to get all traffic from this source MAC address going to this destination, and then all of the return traffic, we'll output that on port 4, and that'll give us everything, but every layer 2 conversation between these two network nodes. Okay, now you've probably noticed at this point that beside our MAC source and MAC destination, we have this plus mask field. So what is this mask all about? Well, what the mask is basically when we specify a MAC address, so let's just drop one in here, we can do a / and then we can set a mask, and that mask is going to consist primarily of zeros as a value or Fs. 0 represents a wildcard, and F represents a strict match. So for example, if we have any given MAC address and we follow it up with a mask of all zeros, this is basically the same, well, it is the same as applying no filter whatsoever, because you're giving a MAC address that you want to filter on, but then you're going to wildcard every value in that MAC address. Therefore, any MAC address would match this filter. So this is the same as not applying a filter at all, which isn't useful at all, really. Similarly, by specifying all F values in our MAC address, we're going to say this is a strict match on whatever MAC address we provide, which is exactly the same behavior as not providing, or I'm sorry, this is exactly the same behavior as just the default filtering on a MAC address. It doesn't give you anything extra, so it also is not terribly useful. But one useful way that we might be able to use this is by constructing our filter like this. So we know that in a MAC address, our first 3 hex pairs represent a unique vendor ID for that specific network interface card. So if we give a MAC address and then we follow it up with a mask like this, and I just inadvertently jumped ahead, but that's okay, where we do a strict match on our first 3 hex pairs, and then we wildcard the rest, this will have the effect of filtering out all of the MAC addresses that belong to a specific vendor. So let's give that a try. Let me fill out the rest here, and we'll just call this vendor ID. We'll apply that rule, and let's see what we get. Fire up my Wireshark capture, and we'll play our traffic. Okay, so this unique vendor ID, which apparently belongs to 3Com, we filtered out everything. You can see this is a different MAC address from this one up here, but it still belongs to 3Com. So we filtered out effectively all of the source MAC traffic coming from any 3Com device on this particular subnet. So one possibly useful way that we can use these masks to filter traffic. Jumping back into our GUI here, let me just get rid of this rule. And then we'll move on to the next component of our masks here. So 2 other potential values of importance that we can put in for our masks are this one, where we have a 0, 1 followed by all zeros, and then we just mask that with a 0, 1 followed by all zeros. This is going to filter out all of our multicast traffic, including our broadcast traffic. Now for both of these, it bears mentioning that these will have to be our destination MAC filters, because I'm not aware of any traffic that originates from a broadcast address. But putting that filter in will separate all of our multicast traffic from the traffic that we're feeding through this filter. And then if we just take this 0, 1 value and replace that so that we have all zeros with a mask of the 0, 1 followed by all zeros, this will have the effect of filtering out only the unicast traffic from the traffic that we're feeding through the filter. So 2 more potentially useful ways to use the masks and a corresponding, in this case, not specifying a MAC address, but using these values in our MAC address filters to filter traffic in some manner that might be useful to us. So that's pretty much everything regarding filtering on MAC addresses. In the next video, I'm going to show the syntax and the command line for accomplishing these same things. And until then, take care everyone, and thanks for watching.